Let's look at this geometric problem. Quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of the diagonal AC is 24 meters. What is the area in square meters of rhombus ABCD? When we talk about rhombus, we shall always know that there are easy way to calculate the area of rhombus. Unlike a rectangle or a square, unlike these shapes, because these shapes has an angle of 90 degrees. Therefore, to calculate their area, we can simply multiply this side length, let's call that A, this is B. The area would simply equal A times B, just the product of the two sides, the two adjacent sides. And even for a trapezoid like this, right? The area formula is expressed in terms of the size, the two bases, and the height. However, for a rhombus, things are slightly different. The reason is this, because these adjacent sides are not perpendicular to each other. There is no easy way to apply the side length to the area of the rhombus. Of course, you can say a rhombus is also a special kind of parallelogram. But even if for parallelogram, how do you calculate the area of this parallelogram? Then we may require the length of this side and then get the height of it, right? Get a height of it, and then that's this side times the height. But for this problem, even if we do that, let's say we do this. We do a perpendicular line from C to the side AD, right? Even if we do that, certainly from the perimeter of this rhombus, we can know that this side length is 1/4 of the perimeter. So that is 1/4 of 52. So that's 13, right? 52 over 4, that's 13. But it's not very straightforward or easy to get this height. Therefore, that's still not a viable or good way to handle that. Instead, for a rhombus, an easier approach to use these two diagonals. How is that? This is because for any rhombus, the two diagonals are perpendicular to each other. Therefore, we cut this rhombus into 4 equal parts, 4 equal triangles, right triangles. Then it'll be much easier to calculate the area. Take this problem for example. Suppose we know that each side of this rhombus is 13, right? And we also know that the AC here, AC is 24 meters. Therefore, let's assume the intersection of the two diagonals is, let's call that O, right? Then OC equals half of that. That's 12, right? I'll write it here. OC equals 12 meters. Voila! I think the problem becomes a lot easier than we thought. Why is that? Didn't you recognize this right triangle? And this is related to one special Pythagorean triple, right? What is that triple? 5, 12, 13. Therefore, this OB equals 5. Then things become a lot easier. Therefore, we can either apply the formula of the rhombus area with the diagonal length. That'll equal a half of the product of two diagonals. Therefore, one diagonal is 24, and the other is 2 times this OB, right? That's 10. So it's easy to calculate this. So that's 5 times 24, that is 120. Or you can do the other way. You can do this first. That gives you 12. 12 times 10, that's 120. So that may be slightly faster. This is one way. Or if you don't know this formula, you can always calculate this area, right? This area. So the area of this right triangle BCO, that equals a half times 12 times 5. And this is 6. That is 30. 5 times 6. And don't forget, this is only a quarter of the whole rhombus. Therefore, the area of the rhombus is 4 times 30, which is 120. And D is our choice. If you like this video, please give it a like and subscribe the channel. If you have questions, please leave a comment.